In this example, we try to graph an exponential function. An exponential function is any function that contains x in the power. Okay, so the difference between x squared, let's say f of x equals x squared, that's a power term because you're getting a power of x. It's x raised to a power. Or in this case, a different f of x, the case we've got in this question, 2 to the power of x, that's an exponential because the x is in the power, the variable is in the power. Okay, so we've got the difference between a power term and an exponential term, something that sometimes can be glossed over and easy to forget. Okay, so let's get on with this problem now. Now, when you go to graph a function, any function, the easiest thing to do is to pick certain values of x. And very often we pick values of x that are close to the origin, close to 0. So let's say we do that right now. And we're going to have x, and we're going to have f of x, which is 2 to the power of x. Okay? So we said we would pick values of x that are close to 0. So let's go from -3 up to 3. Okay. Now that's going to give us, what we're going to do here is, if f of x equals 2 to the x, everywhere we have an x, we replace it with this value of x. So this is going to be 2 to the -3, 2 to the -2, 2 to the -1, 2 to the 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. Now, we've come across this before, but it's likely that you may have forgotten it. What does 2 to the power of -3 mean? Okay, when you have a negative power, what do you do with negative powers? Well, what you do is you move the number under the bottom of a fraction and you make the power positive. Okay, so you move the number under the bottom of the fraction, you make the power positive, and you just put a 1 on top. Okay, so 2 to the -3 is 1 over 2 to the 3. You do this when you have negative powers. So for the first 1, 2, 3 of these, we're going to have negative powers. So that's going to be 1 over 2 to the power of 3. This is a negative power, so make it 1 over 2 to the power of 2, and 1 over 2 to the power of 1. Okay, now let's go back and tidy these up a little bit. So we've got a 1 on top, 2 to the power of 3, that's 2 by 2 by 2, which is 8. Okay, not 6, easy to think of 6. It's not 2 times 3, it's 2 times 2 times 2. 1 over 2 squared. 2 squared is 2 times 2, which is 4. 1 over 2 to the power of 1. Well, anything to the power of 1 just means that same number itself. Okay, now, the power of 0. Okay, if we think about a part of 0, what's a part of 0? Well, a part of 0 is always just 1. Okay, and there may be one exception to that, 0 to the power of 0, but we're never actually going to worry about that one, so just let's leave that alone for now. Other than 0 to the power of 0, anything else to the power of 0 is always 1. So 2 to the power of 0 is 1. 2 to the power of 1 is 2, 2 to the power of 2, 2 times 2 is 4, 2 to the power of 3 is 2 by 2 by 2, so 8. And we can do another one as well if you want to see a little bit more of it. We can go 4, and 2 to the power of 4 is 2 by 2 by 2 by 2, which is 16. So let's turn these into points. Okay, let's turn these into points now. And we do that by doing x and y. So remember, this is actually equal to y. F of x is another name for y. So if we make this into points, we've got -3, 1 over 8, -2, 1 over 4, -1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8, and 4, 16. So those are our points. Now what we have to do is graph them. So if you bear with me a second, I'm going to pull in the graph next. And let's see if I can do this here. If we've got this, and let's just Control V, this should be there already. Yeah, we have it. Okay, so we're going to be scrolling up and down a little bit here to get these points. So the first point, -3 1/8. So let's go to -3. Now 1/8. Where are you going to put 1/8? Okay. Well, here's -3. 1/8 is 1/8 of the way up as far as 1. So it's going to be down here. And all you can do is sort of estimate where you think it's going to be. So it'll be just above the x-axis of -3. -2. -2 is 1/4. Okay, so if we go to -2 and up to 1/4. Okay, so 1/4 is just about there. -1, I won't scroll up. You can scroll up if you want, we'll go back in the video. -1 to the -1 was 1/2, so it's up 1/2. 0 was 1. Okay, and then we had the point 1, 2, and you can check out these points if you want by pausing and rewinding the video. 2 was 4. 3 was 9. And then 4, if we can bring this back in, 4 was 16. Okay, so now you can see that there is a pattern here. There's a couple of things. One is, if we could think about this going backwards for a second, we're up here at the point 416 and we come down very, very steeply, and then it gets very, very shallow. The FOD falls off, but it falls off very, very slowly at the end. Now, you may think that it's going to hit the x-axis, but it doesn't. It never actually quite gets to the x-axis, but what it does is this: it gets closer and closer. So when you draw this, you have to try and draw it showing that, and it's very difficult to do, it doesn't actually touch the x-axis, but it climbs very gradually at first, and then a whole lot steeper as it goes on. And thank you for your patience while I try and do this. Another one of my challenges. So there's the graph. That's the graph of y equals 2 to the x. Okay, there's a couple of things to notice about it. I know this graph's gone on a little bit, or this video's gone on a little bit. One is this point here. This is the x-intercept. Okay, so the x-intercept is 0, 1. The other thing is the domain. It starts all the way out here, right at the beginning of the graph, and it keeps going to the right. So the domain is from -infinity to infinity. But the range, okay, the range is different. The range, it's never going to go down below the x-axis. In fact, it never even touches the x-axis. And remember, the height of the x-axis is 0. Okay, the height of the x-axis is 0. So it starts at 0, but never actually even touches 0. So to show that it doesn't touch 0, we put a round parentheses there. It does climb higher and higher. Remember, range is up and down. So down, the bottom of it is going to be 0. The top of it, it has no top. It goes on forever. So that's infinity there as well. Okay, so those are some features of exponential graphs. Okay.